Hi, we are going to talk about using De Morgan's laws for logic. They're named after a British mathematician, Augustus De Morgan. So let's start with this. A conditional statement: if we like rainbows, that tomorrow is Friday. To negate that, you're going to write it as we like rainbows and tomorrow is not Friday. Symbolically, this can be written like this. When you're trying to negate a conditional statement, P implies Q, not. This is equivalent, that's the symbol for equivalency, to P and not Q. We want to show that it's actually true with the truth table, that they're equivalent. So P implies Q would be true, false, true, true. Not P implies Q would be false, true, false, false. Not Q will be false, true, false, true. P and not Q, so we do this and this will be false, true, false, and false. And you can see that this column here and this column here have identical order of F's and T's. So these are equivalent statements. So does it make sense? Well, let's see. Here's a statement. I'm a math teacher, then I know math. If I'm a math teacher, then I know math. The negated form is going to be according to what we read. I'm a math teacher and I don't know math. I hope that sounds like a logical negation. Let's take a look at this example. It's multiple choice. Choose the correct negation. If it rains, then we are at the beach. That would have to be rewritten according to the formula. The first simple statement and not the second. So it's going to be it rains and we are not at the beach. It rains or not good. It rains and we are not at the beach. This is C. That's the correct answer here. Here we have to negate each statement. So the first statement is if I like mathematics, then the tests are easy. Then our statement will be I like mathematics. And the tests are not easy. If I eat cookie, then it does not rain outside. Excuse me. Will be I eat cookies. And we have to negate this. It rains outside. Now we want to use De Morgan's law to rewrite these negations here. So we're trying to negate not Q implies P. That's going to be equivalent to not P. Nothing's going to happen but the first one. It's going to be and you negate the second one. When you try to negate that, not P implies not Q. This is equivalent to not P. And you negate not Q, which will be Q. What about conjunctions? So conjunction, you eat apples and tomorrow is Sunday. The negation will be you don't eat apples or tomorrow is not Sunday. Symbolically, we write it like this. So not P and Q is equivalent to not P or not Q. Let's take a look at the truth table. So P and Q will be true, false, false, false. Not P and Q will be false, true, true, true. Not P is false, false, true, true. Not Q will be false, true, false, false. And not P or not Q. The only one that's going to be false is the one with both F's. It's going to be F, T, T, T. And you can see that both columns have the same exact thing. That means these two statements are equivalent. Let's take a look at some problems. if Mike likes, I'm sorry, the statement is going to be Mike likes boats and Jenny likes cars. So we need to choose the correct negation. Both are going to be negated and changes to or. So we need to find the one that matches that. Mike does not like boats, or Jenny does not like cars. This is our answer here. So now we want to negate each conditional statement. You watch TV and there is an eclipse tonight. You don't watch TV, or there is no eclipse tonight, right? Example 9. I don't get paid today and you will go out. I don't get paid. I get paid today. Or you will what? Not go out, right? Example 10. We need to rewrite that one using De Morgan's law. So we're negating a conjunction. You negate both and change it to or. So not P, or not Q, which is Q. A disjunction. I have a house or we eat pizza. The negated form will be I don't have a house and we don't eat pizza. Symbolically, this can be written like this. Negation of a disjunction is you negate each statement and change it to and. Let's verify that with the truth table. P or Q will be true, 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 false. Not P or Q will be false, 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 true. Not P is false, false, true, true. Not Q is false, true, false, true. Not P and not Q. Everything's going to be false except the last one where both are true, which is false, 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 true. And these two columns are identical. That means these are equivalent statements. So let's choose the correct negation. Juan likes pizza, or Julia watches cartoons. So we negate both of them and change it to and. So we want to see Juan does not like pizza and Julia does not watch cartoons. So that looks like A. Juan does not like pizza and Julia does not watch cartoons. Let's negate statements. You like meat, or tomorrow is a holiday. It's going to be you don't like meat and tomorrow is not a holiday. I get paid today, or gold is not cheap. To negate that, you get I don't get paid today. And gold is cheap, because we're negating that statement also. To negate this disjunction using De Morgan's law, negate the first one, which is not P, will be P. This will change to and you negate Q, it's not Q. Alright, and now we're going to put it all together. So what we want to do here is take more complex statements and negate them. So each one has to be negated. So remember what we're trying to do here. We're trying to negate this whole thing. So the first thing we're going to do is we're going to just apply that to this conditional statement. So when you negate the conditional statement, you keep the first one, which means it's going to be not P and Q, I'm sorry, or Q. And this is going to change to and we negate Q. And that's the answer. For number 16, so we're trying to negate this here. So we have to negate this statement first, which is a conjunction. So to negate the conjunction, you're going to do not, the first part of the statement. You're going to change it to or, and now you're going to negate not P, which is going to become P. And now you also apply this negation here. So I shouldn't put equal, it should be equivalent. So it's going to be P and opposite, the negation of not Q, which is Q, or P. And that's it. I hope this helps.